We are trying to estimate the area under the curve of f of x equals to negative x squared plus 9. So this is a parabola facing down where x goes from negative 3 to 3. That is the domain that we are focusing on. And then I am trying to estimate the area using left sum, 6 subintervals, right sum, 3 subintervals, midpoint sum, 2 subintervals. Another word for subinterval is subdivision. I said that you do not need to use a graph to do this. Trust me, when you see this problem on the book, you can just go ahead and do what I'm trying to show you next. And you can do the whole thing without using the graph at all. But after we finish the problem, I will show you the graph anyway, because you should have the graph processing in your mind. Okay, let's start from the left sum. The left sum match the color code. I will be using orange. So for left sum, 6 subintervals, first of all, we will be looking for the width, which is delta x. That is the maximum x minus the minimum x, so minus negative 3 divided by 6 interval, right? So let's write 6 intervals instead of 6. 6 divided by 6 is 1, and then this is the width of the rectangle or the base of the rectangle. And then we are going to split up the intervals like that. So we started at negative 3, and then we draw a line. Negative 3, the width is 1, so you jump 1 unit at a time. So plus 1, plus 1, plus 1, plus 1, plus 1, and then you stop at 3. And then make sure you have 6 intervals. So we have 1, 2, 3, 4, 5, 6 intervals. And then for the left sum 6 intervals, so we will be going from left to right. So if you haven't watched my previous video, please do so. For the left sum, the shortcut that you do not need a graph. All you have to do is follow my next sentence. You go from left to right. You grab the first 6 numbers. Again, for left sum, you go from left to right. You grab every number except the last number. So you will be taking negative 3, negative 2, negative 1, 0, 1, and 2. We already have six rectangles right here, so you don't need to take the 3. And then for left sum, so we will be using the delta x, which is 1, and then times f of negative 3 plus f of negative 2 plus f of negative 1, take them all, plus f of 0 plus f of 1, and then plus f of 2. And then if you distribute the 1, you can see that 1 times f of negative 3, 1 times f of negative 2, so on and so forth. 1 times each f of negative 3, so that is negative 1 is the base, f of negative 3 is the height of a rectangle. And then how do we get an f of negative 3? We don't even have a table value. You don't need a table value. For negative 3, this is a function evaluation. You study back in the intermediate algebra. So when x is equals to negative 3, you plug in, right? So you have negative 3 squared, be aware the parentheses, plus 9. So this is equals to 0. And then f of negative 2, you have a negative 2 squared plus 9. So you have a 5. And then what else? Try negative 1, so you have negative 1 squared plus 9. 9 minus 1 is equals to 8, and then so on and so forth. So that is how you do the function evaluation, which the result represents the height of the corresponding rectangle. And then here is the result, L6, that is equals to 1. You have a 0, plus 5, plus 8, plus 9, plus 8, and then plus 5, and then at the end of the day, you have this equals to 35. So this is the area, the estimated area under the curve. Now, do you see that there is a height equals to 0 right over here? So the height of a rectangle equals to 0, that might sound strange, right? Okay, we have a rectangle, the area of this rectangle is equals to 0. Like, what? What does that look like? Let's take a look. I said you do not need a graph, but I still want to show you. All right. So from left to right. So let's fill out the units. So we have the numbers: negative 3, negative 2, negative 1, 0, 1. No, not 0. That is the 1, 2, and 3. Right. And then from negative 1, from negative 3. Negative 3 is a point right over here. So you go 1 unit to the right, and then that's it. Do you see that? Do you see that? This is our first rectangle. the height is equals to 0 because when x is equals to -3, y is equals to 0. So that's why the height is equals to 0. And then the next one is -2. So when x is equals to -2, y is equals to that. And then 1 unit to the right, and then you line up with the -1. And then this is your second rectangle. What is the height equal to? The height is equals to 5 because this is a 5 between 6 and 4. And then the next one is when x is equals to 1, we have, when x is equals to -1, we have this. And then 1 unit to the right, and then we line up with the 0. That is your third rectangle. And then the next one is when x equals to 0, you go 1 unit to the right, and then line up with the 1. There you go. X equals to 1, you have right here, 1 unit to the right, and then you line this up. And then x equals to 2, you have right here, 1 unit to the right, and then you line up with the 3. And then you line up with the 3. Now, if you count the rectangle, it is easy to miss the first one. If you count the rectangle, you say, okay, 1, 2, 3, 4, 5. Where is the sixth rectangle? The sixth rectangle, in fact, is right over here. The height is equals to 0. So when you do the counting, that is easy to miss. When I was learning this, when I was taking my calculus class, yes, I missed it a couple of times. I do the counting. I was asking myself, hey, where is that rectangle? Okay. So that is the left sum, and then for the right sum, so we will match the color code on the first hand. So right sum, 3 subintervals or subdivisions, whatever you like to call. We have a delta x equals to the maximum x minus the minimum x divided by 3 subintervals. So let's write 3 intervals. 6 divided by 3, that is equals to 2. So this is the width of each rectangle. Or you can call this the base of a rectangle. And then we cut the domain. So we have a -3, and then add 2, you have a -1. Add 2, you have a 1. Add 2, you have a 3. So we start right here, and then we can erase the rest. You have 3 intervals, right? 1, 2, and 3. And then what else? This is a right sum. So for the right sum, the phrase that you have to keep in mind is we go from right to left. Again, we go from right to left. We take every x except the last one on the left. So we take every x except the last one on the left, because that gives me 3 intervals already. Back to the previous problem, how come we don't take the 3? Because if you take the 3 and then you go 2 units to the right, there is nothing, because we do not count x greater than 3. So that's why we do not take x equals to 3 for the left sum. Same thing right here. So for the right sum, if you take a 3 and then you go 3 units to the left, there is nothing. That is out of the domain already. So that's why we do not take the -3. Okay, and then for our sum, so we have a R3, so that is equals to the base, and then we have f of 3 plus f of 1 plus f of -1. Of course, you have to do the function evaluation. Simple, just plug in, right? Just plug in the 3, 1, -1 to the parabola function, and then you will get the corresponding y value. So that is 2, and then we have 0 plus 8 plus 8. So that is 2 times 16. We have that equals to 32, and then this is the area of right sum using 3 intervals. And then you might ask me, hey, let's do a quick what if. What if we are trying to do L3? So what if we are trying to do L3? Let's use this color. What if we want to do a L3? What number should we pick? All right, so let's do a quick intervals. So we have a -3, and then -1, and then 1, and then 3. So you have your 3 intervals, right? For the left sum, you will go from left to right. We take 1, 2, 3 intervals. That's it. That is for the left sum. And then last but not least, we have a midpoint sum using 2 intervals. So midpoint sum using 2 intervals, I will match the color code immediately. So for a midpoint sum using 2 intervals, the width of the rectangle is maximum x minus minimum x divided by how many? 2 intervals. 6 divided by 2 is 3, and then this is the width. And then you draw the interval. So we have a -3 plus 3 plus 3. Are we done? No. We are looking for the midpoint. What is the midpoint of each of these interval? So the midpoint is, let's use a different column, the midpoint and the midpoint. Between 0 and 3, 3 plus 0 divided by 2, we have 1.5. This must be -1.5. So for the M2, we will be taking the width times f of -1.5 plus f of positive 1.5. This is a midpoint, not left, not right. We will be taking both. So this is a 3. You plug it in, you get 6.75, and then plus 6.75. And then the sum is equals to 40.5. This is the area using 2 intervals. All right, so the job is not done. I still want to show you the graph. So let's start with the midpoint, shall we? So let's start with the midpoint. The midpoint is we have a -1.5 and positive 1.5. So this is a 1, -1. To be correct, this is a positive 1. Where is 1.5? 1.5 is like right here, right? So 1.5 is like right here. Okay, so let's put a point right there. So this is it's hard to trace the line like this. So I'm going to trace the line. So it's right here. So -1.5 will be like right over here, 6.75. And then how long is the interval? The interval is 3 units long. So we go 1 unit to the right to 3, and then 1 unit to the left to 0. So the length is 3, right? So this is touching the 0, and then this is touching the 3. So there you go. That is your rectangle. And then this one, same thing. And then we line up with the 3. There you go. So this is one interval. The base is 3 times the height 6.75, and then this is another interval. And then what is the area of these two rectangles? The area is 40.5. And then how about the other one? So the other one, I'm trying to use a darker green color so you can see it easily. What do we have? We have 3 intervals. -3, -1, 1, and 3. So we have a -1. I'm going to make this image bigger for you. So we have a -3, and then we have a -1, we have a 1, and then we have a 3. And then from positive 3, when x is equals to 3, we have this point, and then y is equals to 0. So we go 2 units to the right, and then that's it. That is your first rectangle. When x is equals to 1, we have that, and then we go 3 units to the right, and then we line this up, and then we line this up. That is your second rectangle. And then the last one, when x is equals to 1, we go all the way to 3, and then we line up with the 3, and then there you go. So this is your third rectangle, and then your second, and then your first one is right over here. That counts as 1, but the height is equals to 0. That is still one of the rectangles. All right. And one more time, how come we don't use the -3? Because if you take -3, you go 3 units to the right, there is nothing on the right because that is out of the domain. Alright, I think that is the end of this video. If you like the way I explain area under the graph, give me a like, share, and subscribe. Thanks a million for your support. I will see you all in the next problem. Signing out.